A VAM chiller, vapor absorption machine, is a cooling system that uses a heat source, like steam, hot water, or exhaust gas, instead of electricity to produce chilled water for air conditioning or industrial processes, relying on a refrigerant cycle, water, and an absorbent lithium bromide, used in large-scale air conditioning and industrial processes. Unlike electric chillers that use a mechanical compressor, VAMs use thermal energy in a generator to separate the water, absorbent, then condense and evaporate the water to create cooling, making them energy efficient by utilizing waste heat and reducing electrical load. This makes VAM chillers highly economical in facilities where waste heat is readily available. VAM working by 4 main stages. 1. Evaporation. In the low-pressure evaporator, the water, refrigerant, is sprayed over tubes carrying the water to be chilled. Due to the very low pressure, the refrigerant water evaporates at a low temperature, extracting heat and thus cooling the process water. 2. Absorption. The refrigerant vapor from the evaporator is absorbed by a highly hygroscopic, water-attracting, absorbent solution, typically lithium bromide. This process creates a dilute solution. 3. Generator. The dilute solution is pumped to a generator and heated using an external heat source. The heat causes the refrigerant, water, to vaporize out of the solution, concentrating the lithium bromide. 4. Condenser. The high-pressure refrigerant vapor flows to a condenser, where it is cooled and condensed back into a liquid state. The condensed water then returns to the evaporator, and the concentrated lithium bromide solution returns to the absorber, repeating the cycle. Advantages of VAM chillers. Utilization of waste heat. The primary advantage is their ability to run on thermal energy sources such as waste heat from industrial processes, exhaust steam, or solar energy, making them highly efficient in facilities that generate excess heat. Lower operating costs. When a source of free or low-cost waste heat is available, the operating costs can be significantly lower than electric chillers, which use expensive electricity. Environmentally friendly. VAMs typically use natural refrigerants like water, with lithium bromide as the absorbent, which have zero ozone depletion potential and global warming potential, avoiding harmful chlorofluorocarbons, hydrochlorofluorocarbons refrigerants, quiet operation and low vibration. The system has fewer major moving parts, no large mechanical compressor, resulting in much quieter operation and less vibration. Reduced electrical demand. By using heat instead of electricity for the main cooling process, VAMs can reduce a facility's peak electrical demand and associated utility charges. Low maintenance requirements. Due to fewer mechanical components, VAM systems generally require less frequent maintenance compared to vapor compression systems. Disadvantages of VAM chillers. Higher initial cost. The upfront investment and installation costs for VAM chillers are generally higher than for conventional electric chillers. Lower efficiency. The coefficient of performance. The coefficient of performance for VAMs is typically lower, around 0.6 to 1.2 for single-effect systems than electric chillers, which usually have a coefficient of performance of 3 to 5. Larger size and weight. VAM units are physically larger and bulkier for the same cooling capacity, requiring more installation space and a larger cooling tower capacity to reject more heat. Corrosion and crystallization risks. The lithium bromide salt solution used in many VAMs is corrosive, requiring the addition of inhibitors and making the system prone to crystallization if not properly controlled, which can cause system failure. Complex maintenance. While general maintenance is low, when problems do occur such as vacuum leaks, crystallization, they can be complex to fix and require specialized, skilled personnel. Requires consistent heat source. The system is only cost-effective and efficient if a reliable and consistent source of waste heat is available at the correct temperature range applicable. Large buildings like hotels, malls, and hospitals